Today I'm going to be showing you what a polar coordinate is and how we can convert from a rectangular coordinate to a polar coordinate and vice versa. Okay, first of all, let's talk about the regular Cartesian plane. If we have a regular Cartesian plane, normally the point is going to be given in rectangular form, such as, let's say, point 2, 3. Okay, you would plot this point by going 2 units on your x-axis and then going 3 units on your y-axis. So this right here would be the point 2, 3. Now, that is called a rectangular coordinate. In a polar coordinate, what we're going to do is find the distance between this point and the origin. So it's pretty much another way of saying finding the hypotenuse of a right triangle, or because it's polar coordinates, we refer to it as the radius. Okay, and this is where the r comes in. And I'm going to show you how you can convert between them. So first, let me give you a polar coordinate so you understand what it looks like. Okay, let's say we have 4, 30 degrees. Okay, a polar coordinate is one in which the first term is the r. Okay, or the distance between the origin and the rectangular point. And here we have an angle. That angle we call theta. So how do we plot this point on a Cartesian plane? Okay, the first step is to look at the angle. It's 30 degrees. So on the Cartesian plane, 30 degrees is more or less somewhere here. More or less, that's 30 degrees. Now, this 4, all it's telling you is the length between the origin and between this point right here. This is the rectangular point, which we don't know. Okay, so we have the 4. So that is how we would draw a polar coordinate. Remember, start with your angle and then put your radius. Now, here's the thing with polar coordinates. If you see a negative in the front, like let's say this would be -4, 30 degrees, the negative simply tells you that you need to reflect it. So instead of being in quadrant 1, we would draw this same line on quadrant 3. But anyway, the main point. Let's now find how to convert between polar to rectangular. So we want to know our x. Okay, so this is our x, and we need to know our y, because a rectangular point consists of an x and a y. Now, if you remember from trigonometry, there are certain ratios that you use in a right triangle, because that's exactly what this is. This is a right triangle, and we're going to use these ratios of sine, cosine, and tangent to figure out what our x and our y are. So here we go. We have an angle and we have a radius. So let's say I want to find my y. Okay, to find the y, we're going to use sine theta is opposite over hypotenuse. Okay? We have the angle, which is right there, 30 degrees. So I'm gonna plug that in. 30 degrees. And let's see, what else do we have? We have a hypotenuse, okay, which is 4. Okay, so all we need to find is the opposite side, or the y. And in order to find the y, we're going to move the 4 to the other side. So you're going to say 4 sine of 30 degrees is equal to the opposite side, or the y. Okay? And if you plug this on the calculator, it's going to be, make sure your calculator is in degree mode and not in radians. So I'm going to plug in 4 sine of 30 degrees, and I get y is 2. So, hey, I already found this. Y is 2. Okay? And that, notice here, look at this, this formula right here. The 4 is the r. Okay? Because sine is y, then we're going to use sine. And we have an angle, which is 30 degrees. that's where these formulas come in. I just wanted to show you where these two formulas originated from. So let's say if you want to find the y, you're going to use r sine theta. And if you want to find the x, you're going to use r cosine theta. So now I'm going to go for my x. So now I can use this formula and skip the whole trigonometric mess. So I'm going to write it down immediately. I'm going to say x is equal to r cosine theta. R, we know is 4, so I'm going to erase here and I'm going to put a 4. And theta, we know is 30 degrees. Okay, so again, x is equal to, you come to the calculator, and you do 4 cosine of 30 degrees, and you get 3.464, and so on and so forth. So 3.46. So there we have it. Our polar coordinate is 4, 30 degrees, and our rectangular coordinate is 3.46, 2. Okay, so this is polar coordinate, this is rectangular coordinate. So now let's go backwards. What if we want to find the polar coordinate? How do we do that? Okay, so let's do the same thing we've done so far. Let's erase the polar coordinate. Okay, pretend we don't know them. Okay, so I'm going to erase the 4. I'm going to erase the 30 degrees. Okay, so now all we have left are the rectangular coordinates, our x and a y. So how do we figure out the polar coordinate? Well, we need an r. And r is another way of saying the hypotenuse. And because this is a right triangle, we can use Pythagorean theorem. So you're going to say 3.46 squared plus 2 squared is equal to c squared. Okay, and when you do all of that work, you should get 4. So then we ask ourselves, okay, the polar coordinate consists of the r, theta. We have the r, which is 4. So how do I figure out theta? And by the way, theta is always going to be on this side. You're not going to have a theta up here, or obviously not there, because that would be where the 90 degrees go. So if I were to have, let's say, another triangle on this side, it always has to be on these sides. Okay, so if I have another triangle here, it has to be here. Okay, it has to be really the ones that are close to the origin. So again, let's forget about this and go back to what we were doing. We're going to find the degrees. How do we do that? Maybe we can use a trigonometric ratio. But since we already know these formulas, all we have to do is just plug them in. Okay, so let's say we wanted to find the degree. We have an x, we have a y, so you could use either your top formula, which says x is equal to r cosine theta, or you could use your y is equal to r sine theta, because you have both of them. So I'm gonna go for y is equal to r sine theta. They're both gonna work, it doesn't matter. Okay? So the r we know is 4. Sine theta, we don't know what theta is equal to y, and y is 2. The reason I chose this is because 2 is a whole number and this is a decimal. So just to get an exact answer. So we figure this out using algebra. We divide by 4. So we're going to have 1/2 is equal to sine theta. How do you find theta? Well, do the inverse. You're going to say sine inverse of 1/2 is equal to theta. So now on the calculator, I'm going to say sine inverse of 1/2, and I'm going to get theta is equal to 30 degrees. And that's how you get a polar coordinate and a rectangular coordinate. Thanks for watching my video, and subscribe.